Hello everybody. Today I want to take a look at something known as a geometric sequences and series. Geometric sequences in series. So a geometrical sequence is something of this form. You have your first term, your first term times r, okay? The value of a1 is the first term, and r is the common ratio. And r is found by dividing, and that's an n, the quotient of any term. R is the quotient of any term after the first and its predecessor. And the nth term can be determined by this formula here. All right, so let's first, how are we going to identify a geometric sequence? Okay, so here's a sequence of numbers. So 18, 6, 2, and 2/3. Is it geometric? Well, let's start off by writing a2 divided by a1. So the second term is 6 divided by 18 is 1/3. You also get 1/3. And then divided by a3. You'll get 2/3 divided by 2, which is 2/3 times 1/2, and look what you end up with. So all of these right here, you notice we have a common ratio of 1/3, 1/3, and 1/3, and that makes it geometric. So let's look at another set of numbers. 3, 12, 48, and 240. So we're going to have 12 divided by 3. (48) divided by 12, which we get 4. So that's nice. We have the same common ratio. We get 240 divided by 48, and we end up with 5. While these two check out good, this one makes it the whole sequence of numbers not geometric. All right. So let's work our way through these. Writing several terms. Writing several terms. So we want to write the first 5 terms of a geometric sequence. And those are our givens. So solution. Our second term is 5 times minus 2. We get negative 10. Now, 5 times minus 2 cubed. 5 times minus 8. Negative 40. Let's make this first one a 2. Five times 4 is 20. And the last one, minus 2 to the 4th, we end up with 80. So there's our first 5 terms, and that's all you have to do. Now, say we are going to write the nth term of a geometric sequence. So we want to write a formula, and we're going to get some numbers. So write a formula for the nth term. So the first thing we have to do is find out what our common ratio is. So there's 3/2. So the nth term And there it is. Now, suppose we wanted to find a specific term. And we're going to look for we want to find the fifth term. Find the fifth term, where A1 is 15, is negative 9. So you find your common ratio. It's negative 3/5. So to do this, we're going to use the formula to the n minus 1 we have 15 minus 3/5 to the n minus 1. Now we replace n with 5. So we get our fifth term, (243) divided by 125. So I want to show you how this ends up looking. A5 equals 15 to the minus 3/5 to the power of 4. And then from there, that's how we end up with this. Now, for a little more complex, given A2 is 80 and A5 is 40.96 of a geometric sequence, find R, A sub 1 at a sub n. So here's going to be our strategy. So solution. R. So a sub n is 80. So n is 2. So that gives me 80 equals A1R. So now let's do 40.96 equals A1 and we're going to have 5 minus 1, so we're going to get R to the 4th. Now substituting, so substituting A1 equals 80 over R, from our first equation into the second equation, we get 40.96 equals A1 R to the 4th. So we get 40.96 equals 80 over R times R to the 4th. So 40.96 equals 80 R cubed. Divide both sides by 80, we get 0.512. So R equals 0.8. So I'm just going to carry my work right over here. So A1 equals 80 over R, which is 80 divided by 0.8. This gives me, our first term was 100. So we needed that in our formula. So AN equals 100 times 0.8 to the n minus 1. To better understand this question, we were given A2 and A5, but remember in the formula, we have to have a value for A1. So we had to go through this methodology here to compute A1. Then once we got A1, we were able to substitute it back into our equation. So stop the video, go back over it, try some more problems to see how you do these, and redo this same problem over again.